All right, welcome to day 16. For homework, you got the 2021 exam, numbers 1 through 3. Remember, 1 and 2 are calculator, 3 would be no calculator. So we'll go through 4 through 6 of the 2018 exam. Then once this video is done, you'll be able to start doing your homework ones. So we wanted to estimate capital H prime of 6. The best way we can do that from the table is do a change in y over change in x. Make sure to use the points on either side of 6. We get 5/2 meters per year. And the meaning of that means at 6 years, the tree is growing at about 5/2 meters per year. So you needed a sentence explaining that, and you needed the proper units in your explanation. So we want our derivative to equal a non-zero number equaling 2. So we want to be thinking mean value theorem. So we want to be looking for an interval whose slope is 2. So the first thought would likely be to do the slope from 2 to 10 because that's the interval they gave us. But for that, we'd have 15 minus 1.5, so 13.5 divided by 8. And 13.5 divided by 8 is not 2. But if you look at the interval from 3 to 5, you'd have 6 minus 2 over 5 minus 3. So we would have 4 over 2, which is 2. So on that interval, we're guaranteed there's one spot that the instantaneous rate of change, the h prime, has to equal 2. And we need to say that that's by the mean value theorem, and it's because h of t is continuous and differentiable. So because if we're guaranteed there's a spot on the interval 3 to 5, then we're also guaranteed on the bigger interval from 2 to 10, there's some place that h prime of t will equal to. All right, our next one, we needed a trapezoidal sum. And we wanted to do the average height of the tree. So average value, you need a 1 over b minus a out front. So this 1/8 is because of the 1 over 10 minus 2. Now for the trapezoids, we've just got to do individual trapezoids. Trapezoid area formula is 1/2 height times base 1 plus base 2. So I pulled the 1/2 out front. That's why this 1/2 is here. Remember, these trapezoids are really like on their side. So here's your height, here's your base 1, here's your base 2. So the height is the distance between those x values. That's where my 1 is coming from. And then here's my base 1 and my base 2. So it's just the y values on either side of that. And then we had to do that for each of the different intervals. Now, it's your choice how much you wanted to simplify that. So you could have had just that initial line, and that could be your answer, or simplify it for any of those and all the way down to the end. Now, you did need to make sure you had units on it, though. So wherever you decided to stop doing it, you had to have meters on your answer. And the last one is a related rates problem. So we want to take g and do it with the derivative with respect to time. So dg over dt, do a quotient rule there for the fraction they gave us. And now I chose to just do the times dx dt at the end. This is a t here. You could have had individually the dx dt on the 100 and on the 1, and that's fine too. I just pulled it out at the very end, but it would be the same thing. So dx dt they told us was 0.03. We had to find x though by putting in 50 for g in the original equation. That's over here. When you cross multiply and solve, you get 1 for x. So fill in the 1 for x. You got the 0.03 for dg dt. And I switched the 0.03 to 3/100ths just so it's easier to work with without a calculator. Eventually you get 3/4 meters per year. Technically, anything from here on down would be full credit as long as you have your meters per year as your units. So we had a polar one that was no calculator. Probably the most common thing people had was this here for your shaded area. Our polar area formula, 1/2 our integral and its radius function squared. But because we wanted in between two functions, we needed the outer minus the inner. So that's probably the most common one in the right box there, the purple box. You could have doubled that and just done it from pi over 3 to pi, or doubled it and done it from pi to 5 pi over 3, those would be correct as well. And then the other thing I kind of showed here is that really, if we're going from pi over 3 to 5 pi over 3, that's 2/3 of a circle. So you could have, for this part, had it as 2/3 times your circle area formula, and that would have been correct as well. But I'm guessing most people had the right purple box or doubled it and went from one of those to pi for their answer. B, we wanted a slope of a tangent line for a polar, so that's dy d theta over dx d theta. So y is r sine theta. So we had to fill in the r equation in the r spot, do your derivative by doing product rule, and then I filled in my pi over 2, so my dy d theta is -2. Then I did the x is equal to r cos theta, filled in the r expression, did my product rule for the derivative, and then I just, at the end, did my dy d theta and my dx d theta divided by one another. So -2 divided by -3 is 2/3. Now you could have done that product rule all messy on top of each other. That's fine too, and then fill in. I just thought it would be a little less mess and easier to keep track of doing it that way. And the last one was a related rates function with the r. So dr dt is equal to -2 sine d theta dt. They told us dr dt was increasing, so we had a +3 we put in, and then the theta was pi over 3. Sine of pi over 3 is really sine of 60, which is square root of 3 over 2. The 2's wipe out, so you get negative radical 3. Divide that over. So you could, a lot of you probably had that. I end up writing mine as minus radical 3 by rationalizing, but make sure you have radians per second as your units on that. Now, for any of these, if you need more time to look at the answer, feel free to have the sub rewind it and pause it at the specific spot so that you can see your answer. And our last one for 6a, so there's two things that were going on in F. We were replacing the x's with x over 3, and we had to multiply by an x. So in the parentheses there, I replaced all the x's in the original Maclaurin with x over 3, and then I had an x that I was going to distribute. I have my first four non-zero terms. And you could have a variety of things for your general term. I chose to start at n equals 1. So I have n plus 1 in both my exponents, n on the bottom, and then 3 to the n on top. If you chose to start at n equals 0, you would have -1 to the n, x to the n. You would have n minus 1 and 3 to the n minus 1. So you just got to check and make sure it would give you the same thing for that. But then whatever you had for your simplification for the general, use that for your ratio test. Eventually, we have a -1 left over, an x left over in the numerator, 3 in the denominator, and the n and the n plus 1. The n over n plus 1 will go to 1 as n goes to infinity. So we just got to work with the -x over 3, but absolute value of that would be x over 3. And if you did it as -x over 3, you would end up getting the same thing. You would just switch your signs, and it would end up looking like 3 greater than x greater than -3 if you chose to carry the negative through. But it's the same thing. And then we got to check our endpoints. When we put the -3 in, I did the -1 to the n plus 1 and the -3 to the n plus 1. Because they're both raised to the n plus 1, we can multiply the insides and make it to the n plus 1, so that's 3 to the n plus 1. All the 3's wipe out except for one of them, so that's 3 over n. I pulled the 3 out front, and that was the harmonic. So therefore, that's going to diverge. When you put the 3 in, we have an extra 3 on top, but you have the negative to the n plus 1, so you can do your tests for converging for alternating series test. So the 3 is included, but the -3 is not. And then this is just asking us to do our fourth degree polynomials error, so we go to the next term. If we look back up here, our next term after the fourth degree one was this. So we were just taking this term and filling in 2 for x. And technically, any of these things would get you full credit because they all have the same value. So again, if you need the sub to rewind and pause it at any point so you can look at any of those answers more thoroughly, feel free to let them know. And then for the remainder of the period, you're just going to work on your day 16 homework. Remember to be putting those free response questions on a separate sheet of paper. 1 and 2, you can use your calculator, but question 3 should be no calculator. Have a great rest of your day.